Yeah, thank you so much, Pierre, for showing up and for doing this for us. I know it's going to be really interesting, and take it away.
Well, thanks for the invitation. Should we start then?
Let's do it.
Okay, I'm going to share my screen.
One thing I would love, if you can do it, turn your cameras on. Speakers definitely like to see their audience. So if you don't want to, that's fine. I'm going to leave mine on, but if you can, please do it. We'd love to see your faces.
Yeah. Hello, everyone. Nice to see you. Okay, so let me share the presentation. Okay, can you see my screen and can you hear me well?
Yes.
Okay, thanks. All right, then I'll get started then. Okay, so hello everyone. So I'm Pierre, as Ibrahim introduced me. I'm going to talk today about GraphQL in Scala using a library that I made called Caliban. Okay, so I was already introduced. Maybe for those who don't know my name, they might have seen my avatar somewhere on the Zio Discord, for example, where I'm quite active. I'm a tech lead at DevSisters, that is a game company in Korea. So I'm currently in Seoul, South Korea. It's 8 a.m. I just got out of the bed. So I contributed to various open source projects in Scala, mostly in the Zio ecosystem. And I created the two libraries that were mentioned, Caliban for GraphQL and Shardcake for cluster sharding. So today we're going to talk about Caliban. I've done a few introduction talks about Caliban in the past. So today I decided that I was going to dig into more advanced topics so that if you are using Caliban in production, you might be interested to know about, because you're quickly going to get run into these problems. So I will first give an introduction to Caliban so that everyone is on the same page and know what it is about. And then I will dig into advanced topics such as first, application monitoring. So how can you add logs, traces? How can you get metrics about what's going on in your GraphQL server? And then I'm going to talk about query optimization. So I will talk about various problems you can have with GraphQL. For example, try to minimize the calls to your backend database and so on. Try to not query fields that are not necessary. And finally, I'm going to discuss handling context, for example, for authentication, authorization, and so on. Okay, so yeah, and in between each part of this talk, when I get to this kind of slide, I will do a short break for questions. So you can wait for these to ask your questions. Okay, so first, what is Caliban? So Caliban is a library, as I mentioned, written in Scala for doing GraphQL. It has actually two parts. You can develop GraphQL servers and GraphQL clients. Today, I'm going to mostly talk about the server part, not really the client part. What's special about it? So it's purely functional. So that means that when all the APIs are the types from the APIs are telling you exactly what it does. It doesn't throw exceptions. If there's an error, you get a type that expresses that you can have an error, and so on. It's actually based on Zio. It uses Zio internally, even though you can use it with other frameworks like Cats Effect, or you can even use Future if you want. Another thing that's special about it is it tries to minimize boilerplate so that you don't have too much effort to do to create your GraphQL schema. It has great interop. You can use it with a wide range of HTTP server libraries and JSON libraries. And it has a lot of features, as we are going to see in this presentation. Brief word about GraphQL client, the GraphQL client part. This one doesn't only support Scala on the JVM, but it's also available on Scala.js and Scala Native. It's also purely functional, and what's special about it is that it gives you complete type safety, where usually people on the client side, people use strings to query GraphQL servers. Here, you don't use strings, you use Scala. So there's a code generation plugin that generates code from either your server code or from a remote GraphQL API or from a GraphQL schema file. It generates some code, and then you can use that code to write type-safe GraphQL queries in Scala. And if your API, if your server changes, then your client will not compile anymore. So that's the main benefit of GraphQL, the GraphQL client part of Caliban. Okay, so now let's dig into the server part and see how it works. So there are two types of GraphQL libraries, I would say, in general, not just in Scala. Those that are GraphQL first and those that are code first. So when it's GraphQL first, you basically write your GraphQL schema first. So that's what you can see on the right side. And then on the code side, you just write resolvers for each type and each field. The other approach is code first. So the code first is you write code, and then the GraphQL schema is derived from your code. So Caliban is definitely in the second category, even though you can actually, using another compiler, another SBT plugin, you can actually do GraphQL schema first, but Caliban is mostly designed for the latter. So how it works is that you basically create case classes, so very simple Scala case classes. You don't even need an import for that. Like in the example, you have a case class user with an ID and a name fields, and then you have a case class query that's going to be your root query operation with a field me that returns a task of user. I will explain a bit later about the task part. And then from these two simple case class, Caliban is able to generate a GraphQL schema that you can see on the right side. So it's able to convert those Scala types into GraphQL types. And then when you do that, your resolver is just a value of that case class. So that means that to tell what you want to execute when each field is called by the client, you just create a value of this case class that you made. So in this example, we have a user service that has a get current user function. So we just create a query object that has this value calling your function, and then that get current user, we expect that it returns a task of user. So that's just the way you create a schema and a resolver. You just make a case class that is your schema, and you make a value of that case class that is your resolver. That way, the schema is always on the same page as your resolver. Like they don't diverge, as it's sometimes possible with when you do GraphQL first. You have to make sure that your resolver is actually returning the thing that your schema wants. Here, it's necessary. It won't compile if you give a resolver that doesn't return what your schema wants. Okay, now, and we have this object called root resolver. That is because in GraphQL, you can have three types of operations. You can have queries that are read-only. You can have mutation to modify something, and you can have subscription that is more like a receive updates. So you can have three different root operations, and this root resolver can aggregate those three. So you can pass a query resolver, a mutation resolver, and a subscription resolver. Here we only have a query resolver, so it's quite simple. Okay, so I just mentioned that the Scala types are converted to GraphQL types. How does this work? So out of the box, Caliban supports the most common Scala types. So if you have an int, a string, and a list, and so on, it's going to be converted by the equivalent in GraphQL out of the box. It also supports some Java types, such as UUID and some Java time types. It also works with Zio, future cat effect using a proper import, and so on. But then what about your own types? Because as we saw in the previous example, there was a user type and a query type. Those are not like Scala types that are from the standard library. They are your own types. So Caliban provides a system called derivation that is able to generate a GraphQL type for your own case classes and still traits. There are actually two ways to do that. There is auto derivation that works with a single import. That is recommended for getting started because it's really easy. But once you start working on a large schema, it's recommended to switch to semi-auto derivation because you won't run into you will run into less issues than auto derivation because auto derivation can be a bit fragile with large schemas. And with semi-auto derivation, you basically need to add either one line of code if you use Scala 2, or you can use the derives keyword if you use Scala 3, and it will tell Caliban that you need to create a schema from that. If you have your own types that are not case classes or still traits, it's also possible to use them. You just need to write yourself an instance of type class named schema. Let's see a short example here. So we have our own case class user here that has an ID and a name. So if we want to use auto derivation, we just need to import this schema.auto, and then this will just work out of the box. There will be nothing else to do. If we don't use auto derivation, we can add derives schema.semi-auto at the end of our case class with Scala 3. And if we don't use Scala 3, well, if we don't own the type user, we can also create a given schema and call schema.gen. It will generate the schema for us. If you don't use Scala 3, you can do the same thing with Scala 2, except it's instead of given, it's implicit val, but it's the same thing. So by doing that, Caliban will now be able to recognize your case class, your own types, and generate GraphQL schema from it. So in the previous slide, I show how to create a resolver, what to do with this resolver. So there is first this magical GraphQL function, which you pass the resolver to. This function will turn your resolver into a real API object. And that's the function that is going to check that it has a schema for each of your types. So basically, if we don't find a schema for any type inside your resolver that is used in your resolver, there will be a compile error here when you call GraphQL of resolver. So this will ensure that every single type that you used can be handled properly. Otherwise, you will have a compile error. So that's a good way to tell you that you need to add a schema for this or that type. So now you have an API. You can turn it into an interpreter. So this extra step of turning it into an interpreter has two different reasons. The first one is when you transform your API into an interpreter, there are some additional validations that happen to check that the names that you use for your types, for your fields are valid based on the GraphQL spec and a bunch of other verifications. And it also performs some optimizations so that the execution of queries is fast. So it turns your schema into a quite different data structure that is optimized for executing queries. And once you have your interpreter, so that's why the interpreter API.interpreter might fail if your schema is invalid for some reason, like you use some name that is invalid. Once you have the interpreter, you can call the execute function and pass a GraphQL query, and it's just going to run the query as expected. In your own code, though, you don't really want to call execute yourself. Usually, you want to expose your GraphQL API by HTTP. So there are some components called adapters that take your interpreter and turn it into an HTTP server, basically. So we have an adapter for each of those four popular Scala HTTP libraries: HTTP4S, DOHTTP, AK HTTP, and Play. And actually, under the hood, those adapters are built on top of another adapter for Tapir. If you don't know Tapir, that's a library that allows you to define HTTP endpoints with a DSL, and then you can turn those endpoints into a server for a lot of different HTTP libraries. So to make our life easier in Caliban, we built a Tapir interpreter, Tapir adapter, and then thanks to Tapir, we can turn it into an HTTP server of any kind that Tapir supports, basically. One more thing is the JSON library. So usually when you use HTTP, GraphQL, the GraphQL is the response is in JSON format. So for these two, thanks to Tapir, you can use any JSON library that Tapir supports. You just need to add an import coming from Tapir with whatever JSON library you want to use. So you can use source, JSON-iter, ZioJSON, and more, play JSON as well, and so on. So how do you use your interpreter? How do you make it into an HTTP server? First, you transform that GraphQL interpreter into an HTTP interpreter. That is actually the Tapir interpreter. And then we have this helper function, so HTTP4S adapter.makeService. Then you give your HTTP interpreter, and it turns it into an HTTP4S route. And you can do the same thing with the four libraries mentioned on the left. There is an adapter for each of them. And then you just, once you have your, for example, HTTP4S route, you can just pass it to your HTTP4S server alongside your existing routes, or as just the only route, then it is up to you. So it's super easy to turn it into an HTTP server. Okay, so yeah, that's for a brief overview of the basics of Caliban, how to make a schema, how to make a resolver, and how to expose it. Before I go into the next topic, are there any questions?
We have a question from Joe.
Yep.
Yeah, so in that example, you had like the most simple repository possible, which is just a get method that is a task that returns value.
Yeah.
How are like filtering or queries or anything like that implemented? Filtering or any kind of conditional query or anything that's more complicated than get them all.
Yeah, okay. So one thing that I didn't show here is like, so GraphQL can have arguments. GraphQL fields can have arguments, right? So the way this is expressed with Caliban is just a function. So for example, your type query, currently it's me returns a task of user. Let's say instead it's called search, and it takes maybe a query string or like a name, and it returns a list of users, right? So you would change the type of the field. Instead of a task of user, you would make it to, let's say, search args to task of users, task of list of user, for example. So search args is a type, and then arrow to a task of list of user. So your field would be a function, basically. The type of your field would be a function from an arguments type to your result type. And this args, let's say search args type, that would just be a case class with a list of fields. And all those fields would become your GraphQL arguments. So yeah, so that's how it works. And then your resolver is just basically a function from these arguments to your own logic. So you can use the value coming from those arguments.
And so those arguments can be arbitrarily typed. They're, I guess, marshaled in from HTTP, and then it's kind of up to that function to interpret them as some kind of filtering logic or whatever.
Yeah, so in GraphQL, there are two ways to provide arguments. They can be directly in the query string, like kind of hard-coded, or they can be variables. In that case, the query string only has like $, $sign, and some variable name. Mm-hmm. And in that case, the variables are passed also as a part of the query, in the JSON format usually. And then Caliban takes care of parsing those arguments, replacing them in the query. And then when it calls the actual field that requires the arguments, Caliban will pass the actual case class that has the arguments. And yes, you're right. Here, for example, I talk about schema. So schema is for like the output types, basically. Whenever you have arguments somewhere, if you have a type that is passed as an argument, there is another type class called argbuilder that defines how to basically go from the JSON format to the case class. And there is also auto derivation and semi-auto derivation for this argbuilder. So it can be automatically generated, or you can pass your own function, your own code if you want to write a custom argument parsing, let's say.
And are updates modeled as like a stream or some kind of infinite data source?
Yes. So in the case of subscriptions, basically the root fields need to be ZIO streams. So yeah, similar here, instead of task of user, you would have a Z stream of user, and that would work for subscriptions.
Okay. And what if your schema includes recursive reference? So let's say user has friends, right, which is a list of user. Are those how would GraphQL in general and maybe Caliban handle that?
So GraphQL does support like recursive types. There is no problem with that, because it's lazy, right? You only return what the client asked for, so it doesn't really matter if it's recursive. In Caliban, well, there are two things. First, well, I'm going to talk about, in the part 3, I'm going to talk about laziness, like how to not query too much. So I'm going to explain this a little bit later. Like how you, because of laziness, you will avoid like infinitely trying to get data. And secondly, one thing that is a little tricky, but good to know, when you have recursive types, you need to make the implicit val lazy in Scala, or the given need to be lazy, because otherwise you might have a loop of, the compiler might run into a loop.
Right.
Yeah, so you need to make your implicit val lazy. That's the only tricky part. But for the execution part, I will explain in the third part how laziness is handled.
Right, and you're saying that GraphQL doesn't let you express an infinitely nested structure in that way. You have to specify the depth of the data returned, and so it's naturally bounded. Yeah,
because the client says like what they want, right? So, right. And there is also well, actually, I think it's possible to make cycles actually when using fragments. But during the validation of queries, there is a step that checks that the query is not infinite. And if it is infinite, it just rejects it.
Okay.
So cool. In case there is like a malicious attempt at making an infinitely, yeah, this would be rejected.
Okay, thanks. That's all I had.
Okay. Was there anything else, or should I go on?
Reed just raised his hand.
Yeah.
Yeah. You mentioned that you could, I think it's interact with ZIO or cats, but you said for the streams like return type, it needed to be a ZIO stream or a Z stream. Could it also be like a FS2 stream or something else, a supported IO stream?
Yeah. So actually, there was a PR to add FS2 stream support, and that was merged yesterday. So this is very, very recent. It's not released yet, but yeah, someone added. Well, it was already possible before, but you had to write a little bit of code, but not very long. Basically, a transformation, a conversion between FS2 stream and ZIO stream. So yeah, it's definitely possible. It's just that under the hood, a ZIO stream will be used, but since there are like interrupt libraries, like there is a ZIO interrupt cats libraries that has conversion between FS2 and ZIO, so you can do it kind of seamlessly. But under the hood, it's still going to use ZIO stream. Okay. then I will go on. That's fine. All right. So now let's discuss application monitoring. So if you want to use GraphQL in production, for sure you're gonna want to have some of these, at least logs, probably metrics, even traces. So let me explain how it's done in Caliban. First, I need to explain what happens when a client sends a query, GraphQL query, into any kind of GraphQL server, really. There are always three phases for handling the query. First, the query string is transformed into an ADT. It's called a document in the spec. So it's the parsing phase. We check that what the client sent is valid. We turn it into something that we can understand. The second phase is the validation. So we check that this ADT is correct. I just mentioned that we check that there is no infinite loop, infinite recursion in there. We also check that it matches the spec, that there is nothing illegal in regards to the GraphQL spec. And we also check that it matches the schema. So if there is like the client requests a field that doesn't exist on the server, it's also rejected. And after that, once it's validated, we can actually run it. And the execution phase just runs the resolver for all the fields that were requested by the client. So those are our main phases. Then Caliban has the concept of wrapper. So a wrapper is kind of a hook that you can use to wrap one of the phases or the whole thing. Wrapping it means that you can basically execute some code before, after, or you can even replace the whole phase if you want to. So we have a bunch of wrappers. There's the overall one to wrap the whole process. You have the parsing wrapper for the parsing phase. You have one for the validation phase, one for the execution phase. During the execution, you also have one for each individual field execution. And this one allows you to do every field or only the fields that are not pure values, because sometimes when it's just values, there is not real benefit to wrap them, but when they actually call a database or something, then you want to wrap them. And then there's also a wrapper only for introspection. For example, if you need to set permissions, like you don't want to allow anyone to introspect your schema. So how do those wrappers look? So in the code, it's not exactly that, but this is more the logical meaning of a wrapper. So a wrapper is a function from a first function from an input to a zero of either an error or an output to a new function that has the same signature. So the function from input to a zero of output is basically the process running our phase, like running our parsing, running our validation, or running our execution, for example. So for each wrapper, the input is different. For example, for parsing, the input would be the query string, and then the output would be the parsed document ADT. In the case of the execution, the input would be the ADT, the parsed ADT, and then the output would be the actual response that we send to the client. So you have this function, and you replace it with another function, which lets you basically, it gives you access to the input. So you can do something before running the ZO. You can run the ZO or not run the ZO if you don't want. You can fail, or you can run something at the end of the ZO. You can map the ZO to change the output, for example. So you turn the first function into another function. Let me show you an example. So let's write a simple wrapper for printing if there is any error. So for that, we are going to use an overall wrapper. So we are wrapping the whole thing. And we have to basically implement a function called wrap that takes the first function. So it takes a function. In the case of overall wrapper, you get a GraphQL request as an input. So that's an object that contains the query string and the variables values. And then this function returns a zero of nothing. Nothing means it cannot fail. And then GraphQL response of Caliban error. So it's basically your GraphQL response that can contain data or that can contain errors. And we have to return another function with the same signature. So how do we do that? Well, we make a new function so that takes a request, and then that returns the original process. So we call the original function. So it means that we first run the execution of the GraphQL request, and then we call tap. So tap is kind of a flat map, but it doesn't modify the end result. So we just tap, get our response, get the response that was returned by Caliban, and then we check if response.errors is not empty. Then we want to print something in the console, print the list of errors. So this wrapper, we just run the original code and then just do something at the end to check if the response has errors, just print them. Okay, so that's a very basic example of a wrapper. So you can see in just like a few lines of code, you are able to add extra printing, extra logging at the end of your request. So Caliban comes with a lot of built-in wrappers. So there are wrappers for validation, for checking, for example, that your query respect a maximum depth or a maximum number of fields. It's quite useful if you want to make sure that no one is like trying to do something too crazy with your API. You can also compute a cost. So if you're, for example, you want to make your API a paid API, and like, let's say customers are charged based on how much they use the API. So we have an example of cost calculation. You can, of course, make your own. And you can reject queries also if the cost is too expensive. You can adapt those wrappers and call some external API to maybe charge something for every query, and so on. There is also a timeout wrapper if you want to interrupt any query processing that takes more than a specific time. Then we have wrappers for logging, like the one I just showed before. So you can print errors, you can print or log slow queries. We have wrappers for metrics, so that they add, like, for example, time spent per queries as a metric. And there's another one for adding traces. So create a root span for every query, and so on. And then maybe if you use GraphQL before, you know Apollo, or you used it. That is the most popular client-side library in JavaScript, in the JavaScript world. And Apollo has a lot of plugins. And using wrappers, Caliban can support many of those plugins. So we can support Apollo tracing, Apollo caching, Apollo persistent queries. What's interesting is that all of those wrappers are written on top of the existing Caliban. So it means that you can support some additional spec, like, for example, Apollo tracing will add some metadata, some in the responses of your server. So you can add that without modifying Caliban. You can completely do it in your code on top of Caliban, just using a wrapper. You can basically modify the behavior of Caliban and add things in your response or other various logic. Okay. How do you use those wrappers, like the one we just created? So when you have your GraphQL API object that you get by calling the GraphQL function, you just basically tag the return value of this GraphQL function with your wrappers. So you can stack multiple wrappers on top of each other. So in this example, we have our API, and then we will check that the API, the queries don't have a depth more than 50 levels of nesting. We will time out if the handling takes more than 3 seconds. We are going to print any query that takes more than 500 milliseconds, and then we are going to add supports for Apollo tracing and Apollo caching. These few lines do all of that by adding all of those wrappers to our API. Okay, so that's for the wrapper part. Do you guys have any question about it?
We got a question from Reed.
Hi, we talked about infinite, like recursive schemas and infinite queries. Does the max depth protect against that? Like if you leave off max depth, couldn't you?
Yeah. Well, the
query
actually the
infinitely, or is that
yeah
baked into the actual spec of GraphQL?
the spec will prevent infinite ones, so the infinite ones will be rejected during the validation phase. Like that's the spec. The depth would be more like if someone tries to make something like crazy deep, like sending you a query that's like really really large, that
Really
would
heavy
prevent
query
that.
on your server, right? Like,
Yeah. But yeah, the
awesome.
infinite
Thank
ones are just protected like natively because the spec has actually a check for that.
Dope. Thanks.
Okay, I will continue. All right. So the next part is query optimization. So I'm going to actually discuss two different things because there are various problems. So the first one is more about dealing with the nesting and the n+1 problem. Maybe you've heard about that. And the second one is more about when you have really a lot of fields and you don't really want to query them all. Okay, so let's see the first one. So here I have a small example that we have case class queries that has a customers field that returns a task of list of customers. And then to implement the resolver, we need to have a function get customers that returns a list of customers. You see that in the customer case class, you have orders, which returns a list of order. So the question is here, when I query my customers, it seems that to create the values of type customer, I also need to query all the orders, right? But maybe the client, when they do their GraphQL query, they didn't request the orders. But do I still need to query my list of orders if the client did not request it? Like, how can I handle that? So the solution here is if there is something that is expensive to query, make it lazy. By making it lazy, it means that it will only be queried when the client actually requests it. So if orders is just a list of order, you always need to provide it, right? But if you change order to a task of list of order, so here I put a task. This is a zero task, but it could be any type of zero. It could be a cat's effect, or even if your code is not using zero, if your code is not like purely functional, you can use a function from unit to a list of order. That would be the same thing. So basically, by making it lazy, it means that you don't need to provide a list of orders right away. You just provide a function that returns a list of order. And when you do that, it will only be called if the client requested the list of orders. So you can have task or ZO or function from unit to something, not just at the root level, but anywhere in your API, anywhere in your schema, you can use lazy fields if you don't want to request it right away. But then you can run into another problem. So here, let's see, we have the same example. We have our get customers function that first call the database to get a list of customer IDs. And then for each customer ID, we are going to call a function get customer. So this is okay. And then get customer will call the DB again to get the customer. And then it will return a customer object with the customer ID, the customer name. And then, as we just saw before, our list of orders is lazy. So it's a zero for each order IDs that we get from the customer, call get order. Okay, so this is great. If the client doesn't request order, we're not going to do that zero for each. It's going to be quite cheap. However, there is a problem here. How many DB calls are we going to do? Let's say you have 100 customers. The first for each is going to call get customer 100 times. And then if we actually want the orders, let's say we have 50 orders. So 100 calls to get customer, and then for each get customer call, we're gonna get 50 get order calls. So as you can see, it can get exponentially large, and you're gonna do a lot of calls to your DB backend. How do we handle that? Well, there is actually a great solution in the Zio ecosystem that is called zQuery. So you see the code here is basically the same code as the previous one, except I replaced Zio by zQuery. And just by doing that, when I run this code, instead of doing like 100 call to get customers, it's going to do 1 call to get customer. And instead of doing 100 times 50 calls to get order, it's going to do 1 call to get order. How does this work? There's actually a little more behind it. It's not really just magic. So to have zQuery work, to return a function with zQuery, you actually need to implement something that's called a data source. And when you define your data source, you basically say how to query not just one, but multiple of a given object. So here we have our request type is get customer. So we are going to implement a customer data source that define how to query multiple customers at the same time. So it's a function from actually a chunk of get customer to a task of chunk of customer. Chunk is a Zio, it's a type from the Zio library that is efficient list type, basically backed by an array that is good for concatenation. So by implementing this data source, you say how to query not one, but multiple instance of that entity. And to implement get customer function, you pass that data source, basically. And then zQuery, when you actually run the code that I just saw before, zQuery will be smart enough to find that there are multiple calls to get customer, and it's going to merge them together so that it calls your optimized function and query all of them at once. So what zQuery gives you is deduplication. So if the same ID is called multiple times inside your GraphQL query, it's going to be called only once, and then it's going to be cached. Gives you batching. So if there are several calls to the same type of entity in multiple places, they're going to be batched together into a single call. As long as you provided that function that tells how to query multiple at once. And you can also control the parallelism pretty nicely, like if you want things to happen in parallel or sequentially and so on. So Caliban supports zQuery out of the box, so you can make your schema case classes return a zQuery, and it's going to just work same as a Zio. In fact, Caliban uses internally zQuery as its main effect type. Okay, so that's the way to handle nested queries. But there is another problem that is pretty common. Let's say you have a database. In your database, you have a very large table with a lot of fields. So for example, here we have a root query type that is movies, returns a list of movie. And then for each movie, you have like a lot of fields. Maybe the client will just request the ID and the title. But in your database, you have like everything. So those subfields are not like they are in the same table. So you don't really want to make them lazy. Like you don't want to call a specific function to get each of those fields. You still want to query them at once when you query the list of movies. But is there a way to not query all of them? So there is, and that way is called field metadata in Caliban. And basically what we call field metadata is that you will turn your case class field into a function. Instead of being just a task of list of movie, you make it a function from field to a task of list of movie. Field is a Caliban type, is a Caliban.field. And that type field gives you some metadata about what the client requested. By the way, here I put also an example of search. So if search is a function from search args to a list of movie, you can also make it. You can also add fields on the top, and it's going to be a function from field to search args to a task of this token. This field function will be ignored in terms of generating a GraphQL schema. It will be invisible, but it gives you this metadata that you can use in your business logic. So in field, you have the field name, the field type, parent type, arguments, directives, and so on. But the most important part usually is the inner selection. So it contains what are the subfields that were requested by the client. So let's see here, we have our getMovies function. So now we can take as an input this field metadata, and then we can check at the inner fields, map to their name, and then basically you can build the SQL query by only requesting fields that were asked by the client. So that is really neat if you have like large flat tables with a lot of things in there and you don't want to query all of them. You can dynamically generate your SQL query based on the fields requested by the client. And if you don't want to do this manually, and if you are using Quill on Scala Free, so ProtoQuill is the version of Quill for Scala Free. There is actually direct Caliban integration, so this works out of the box. So basically, the way this integration works is that you have to put some import, and then it gives you two functions, filter columns and filter by keys, that automatically filter your SQL query to only request the columns that you want and to filter by some ID. So if you're interested in this and you use Quill, I encourage you to check the ProtoQuill documentation, and there are some examples of how to use that. And this is basically just using the field metadata that I mentioned just before. Okay, so that's it for query optimization. Any question?
Got a question from Joe.
Yeah.
Yeah, so in that example, you had a case class that had a bunch of fields in it. If the user optionally selects some, how do you construct that case class without values? Like, do they all have to be optional?
Oh yeah. So when you let's say for example, if I go back here, let's say I only selected a couple of fields. You can for what do you pass for the other fields, right? Basically, it's kind of, it might sound a little weird because we are in a functional FP, but basically you give null to the other fields. The reason it's okay to give null to them is that, well, first, or you can also give a default value if you want, or null. The reason it's okay to pass null is that those fields will never be accessed, basically, because if they are not requested by the client, Caliban will never call them. So you can just pass whatever, basically, null or default values, they will never be accessed.
Okay. So we're kind of maybe that is that schema intended to be like, it's almost used more like metadata than it is potentially as like business objects or object or domain objects, right? In this case, that maybe is more important to describe the shape of the response in GraphQL than it is to actually for the client to handle that as a Scala object. And so it doesn't matter if something is null, right?
Well, the movie type, in this case, the movie type kind of reflects what you have in your database. So it's kind of your domain object that has everything. Because the client can request anything from it, right? So we can't have a different case class for everything that the client might ask, right?
Right.
So that's why the movie has everything, and then but then when you create a movie, let's say by reading it from the database, you actually only need to fill the fields that were requested by the clients, and that's what this field metadata gives you. It's what fields were requested by the client.
Okay, so when you say default value, like that case class is being constructed. It's not just being used as schema metadata. But
yes.
That int can be a 0 because it will never be returned.
Yes.
Got it. And then, in the example, you had some text being concatenated together to form an SQL query. So I presume that, like earlier you spoke about validation, I would assume that any list that we get from the client is sanitized, right? So is this a safe thing to do?
Yeah, it would be only fields that actually exist in your API, because if the client sends a field that doesn't exist, it will be rejected during the validation phase. So it will never reach the execution.
Got it. Okay. That's all I have.
Reed has a question.
Yep.
Yeah. Why not make everything a field? Why stop at only the ones that are like very flat case classes? Why not make everything a field?
I mean, you can you can do it at any level. Basically, the making it a field is it's only useful if you actually going to use it in your implementation, but you can use it at any level, including not at the root, but inside, like at a nested level as well.
Okay. Cool. All right. Cool. Thanks.
Actually, I have a question. Oh, sorry. And Navid has a question.
I mean, feel free to jump in. I just wanted to ask something about the nulls. You said there's literally no way that Caliban can call them. I wanted to ask you whether those wrappers you talked about earlier could potentially access those things. Or like
no, actually, the wrappers don't really have access to the resolvers. Basically, the resolvers are used during the execution phase, so the third phase, and the execution wrapper just gives you it gives you an effect, but yeah, it just gives you an effect that runs the resolver. Or if you use the field wrapper as well, if you use the field wrapper, you have it gives you an effect that runs that field, but you don't know what's happening inside. So the wrapper can do something before, after, or replace it, but it doesn't know what's happening inside.
But like if I tap on it and get the actual thing that it generated, can I not get those nulls?
No, because if you tap on it, you're gonna have the GraphQL response object, which is already it's not the case class. It's basically something that's a bit like JSON. It's called value response value. That is something a bit like JSON. We convert it to JSON actually when we return it to the client. So it's only the GraphQL response. So it's not gonna have those fields.
Yeah, thanks.
There was another question, I think.
Yeah. So my question.
Yeah.
Going back to kind of like what Joe was asking about, like when the case class gets constructed, you said that, for example, if you select only for that really big case class that has a bunch of fields, if the client wants only ID and title, for example, you said the other fields could be assigned like a null or a default value. So at the time that the case class gets constructed, what would it look like?
Yeah. So basically you have to return, let's say in this example, you have to return a movie, right? So you have to make a new case class, a value of a case class movie, and you only have, let's say, ID and title, but you still need to create it, you still need to give values to the other fields. So that's where the value is actually not really important. So that's where you can pass either, like, let's say year could be 0 or year could be null. It's not really important because it's never going to be used.
Gotcha. So it is there. It's just never really used. Or
yeah. You just need to give it a value in order to create the object, but the value is never going to be accessed. So it is not really important. Or you could have a default movie, for example. You could have a val which is default movie, and then you only replace the fields that you have, something like that.
Okay.
So like empty movie dot copy, and then just
for example, yeah.
Gotcha. And the other question that I had was, in case that you're using streams, will this work just as well? Like if you're using zQuery or?
No, zQuery. Well, so in the case of streams, I think zQuery doesn't really work with streams. It's a little different. Well, it depends. The root, in the case of stream, the root needs to be a stream. Inside of the stream, you can have lazy fields and jQuery as well, but the root is a Z stream, and it doesn't really, it's not really relevant in the case of the root stream. But inside of the stream, you can have like objects, and they can have their own jQuery and so on.
Okay, yeah, that's pretty much what I wanted to know. Awesome.
Okay. Okay, so let me cover the last part, which is about authentication and context in general. So one very typical case that you can have if you use GraphQL in production is that you might want to verify that a request comes from an actual user by checking maybe a token, and then reject invalid requests that are not authenticated. And then if it's a valid request, you want to save some user information inside some context that you want to reuse in other places of your API. Like in the resolver, you want to access the context maybe. So with Zio, typically we handle context by using the Zio environment, which is the R parameter of Zio. So typically here you have a query, a root query type, with a function do something, and it returns a RIO of user context and unit. So RIO is a Zio that can fail with an exception. And here, the first type parameter, user context, means that we have a user context that we can access, and our effect will return a unit. So here is an example after the do something function shows you how you access this context. So you can call Zio.service with Zio, or just Zio.service if you don't want to do other effects. And this gives you that user context object. When you use that in some places of your schema, when you create your resolver, when you call the GraphQL function, you're going to get a GraphQL object of user context. What that means is that in order to create your GraphQL function, at some point, you will need to provide that context. Right, so it's similar to dependencies. Like when you have a dependency in your Zio environment, you need to provide the dependency at some point. Okay, so now let me explain another concept, that is the concept of interceptors. That is a little bit like wrappers, but at a higher level. Wrappers are really during the execution of the query. Interceptors are more at the HTTP level. So an interceptor, I put here what's the actual type of it with ZLayer, but if you're not super familiar with this, you don't really need to understand what it is. I put above what the logical meaning of this is. So it's basically a function from a starting environment, R1, and a server request. A server request is, it's actually a Tapir object that contains the headers, the body, and all the stuff coming from the HTTP request. And then that function returns either a Tapir response. So in case of errors, you want to return basically it's a HTTP response that let's say it's a status code 400 or 403 and so on, and a new environment R. So an interceptor basically gives you access to the HTTP request, allow you to fail, and allow you to change the environment from R1 to R. So let's see a simple example here. I made a type alias auth interceptor. There is an interceptor of any and user context. So that means that it's basically taking a server request and returning either a Tapir response or a user context. So in this case, we change the environment from any to user context. So it's auth interceptor is basically creating a user context for you. Let's see how we would implement this interceptor. So we will, as I mentioned, it's a ZLayer. ZLayer is a Zio type that is nice for combining dependencies together. Let's say you want you need an A to get a B, and then you need a B to get a C. ZLayer allows you to easily combine all of these dependencies. In this case, it's much simpler. So we just create our ZLayer from a Zio, and our Zio is access the server request from the environment that gives us this request object. and then check the header called token, and see if we have this header. If we find it, we create a new user context that contains this token. If we don't find the header, we fail with a response saying it's forbidden. In practice, like here, I don't even validate the token, but in practice, you would also validate the token, and maybe in your user context, instead of the token, you would put maybe the user ID or the user information, and so on. But for the sake of for the example to stay simple, I just put the token in the user context. And then so we have this interceptor from any to user context. And now let's see how we are going to use it. So you remember before we had our GraphQL API of user context. When we turn it into an interpreter, we get a GraphQL interpreter of user context, and E is an error type. Usually it's Caliban error, but you can change it to your own error. Not relevant here. Then you change your GraphQL interpreter into an HTTP interpreter. That's the Tapir one that I mentioned before. So you still have this HTTP interpreter of user context. And then you can call HTTP interpreter dot intercept and pass your auth interceptor. And what changes here is that now the return type is an HTTP interpreter of any. That means that you no longer have that user context requirement in your interpreter. You no longer need to provide a user context to run your API, because it's being provided by the authentication interceptor that we saw before. You see, this authentication interceptor out of any is able to create a user context. So that means that we don't have a need to provide a user context anymore. It's provided by the interceptor. Then we can turn this auth interceptor into an HTTP forest route. So what do we use those interceptors for? So the most obvious use case is authentication and authorization. As I mentioned in the example, you can reject wrong queries. You can inject a context that can be used later in your APIs. It can also be used in wrappers. So for example, let's say you want to verify everywhere that you have the proper permissions and so on. You can inject permission data in your context, and then in the wrappers, potentially even in the field wrapper, you can check if each field is allowed for a given permission. You can use that also for extracting tracing information from HTTP headers and then injecting it into the current span. If you use something like open tracing, for example. And then a simpler use case of interceptor is configuration. So because we use zLayer, basically all the GraphQL request execution will happen in a single fiber. So using fiber ref, you can locally modify the value of like a configuration variable or something that is stored in a fiber ref. That's actually how we use how we configure, for example, enabling or disabling introspection or enabling or disabling validation. That can be done using an interceptor that is modifying a value stored in a fiber ref that locally changes the behavior of your request execution. So you can dynamically, for example, say, if it's this user, then disable validation, or if it's this user, enable introspection, stuff like that. Okay. Well, I talked about a few aspects that are quite useful when you use GraphQL and Caliban in production, but just to let you know that there is way more that you can do with Caliban. You can do things like stitching and federation. That is, you take several GraphQL APIs, different APIs that can be even not with Caliban, or they can be using different languages than Scala, and group them together in a single API. So either you do that kind of manually using stitching, and then expose the schema, the final GraphQL API yourself, or you can do this using Apollo Federation. That is actually a gateway provided by Apollo. So in this case, it's their gateway, but you can use Caliban as a backend because Caliban implements their federation protocol. There is also a schema comparison, so you can compare an old version of an API with a new version of an API and see if there are any differences. I even know people who use that in the CI to automatically find if something changed, generate a report, and so on. One thing that is really cool is you can generate a client from the server code. If you use Caliban on the client and on the server, both, it's really cool because you can write your GraphQL client code. And let's say if you remove or you rename a field on the server side, then your client code will not compile anymore. And you will find that all at compile time. I think that is pretty unique in the GraphQL ecosystem in general, not even just in Scala. There is support for the defer function. That is a new spec, a new thing in the spec that allows you to return the first result fast and then return additional results later. When you have things that are maybe a little more expensive to compute, you can return the data to the client in 2 steps. There's also support for relay. There's a kind of protocol on top of GraphQL to handle things like pagination and like request more data and so on. There's also support for schema reporting. That is reporting your schema and schema changes to some URL. And so on. So there are a lot of different features that I encourage you to check out. Check out the docs. The docs have details about all of these if you are interested. Okay, I think that's it for me. I hope you found it interesting. I hope it makes you want to check out Caliban and the advanced feature were quite interested to you and useful if you want to use it in production. So you can check the website here. As I mentioned, there are quite large amount of documentation. There are also some example projects, example code on the GitHub. I recently enabled GitHub sponsors. So if you use the library, if you like it, you can show your support this way, you or your company. And I'm just to as a little extra, I'm currently working on a book that would be about full stack GraphQL in Scala, showing the full extent of what Caliban can do. But I'm just starting, so it might take a few more months until I have something to show. But yeah, stay tuned, and I can answer more questions if you guys have any.
Awesome. Thank you so much, Pierre. Yeah, Joe has a question.
Oh, I have a few questions. So you mentioned introspection, so I assume that introspection is fully supported based on the schema that you provide?
Yes. Which is especially useful, like for example, when you develop, there are tools. There are tools that can introspect your schema, and then, like for example, like Postman or Insomnia. There are like similar tools just for GraphQL, and using introspection, they can know what your schema is and help you. Like you have auto-completion when you write queries and stuff like that. But you can. That's something that sometimes you want during development, but you might not want in production. So that's why I mentioned there are ways to disable it if you want.
And this is a question for any Scala library that gets wide use. What does the Java interop picture look like? Like difficult because this uses a lot of Scala features, or is it possible?
You mean to use the library in Java?
Yeah.
I actually have no idea because I actually never used Java professionally. I don't come from Java world. I would say, I mean, it sounds difficult because of, I mean, just the schema derivation is relying on like macros and stuff. But I have actually no idea. I have no idea what Java can actually run. I mean, maybe if you compile your project in Scala, no, I don't know. I mean, on the resolver side, you can wrap Java code in Scala. Like you can have a,
right.
So that part is quite easy. But then I would imagine like the the top level side, like the API, exposing the API, that would be better to stay in Scala, I guess, for that.
Mm-hmm.
Because once you have your API, the only thing usually you want to do is just expose it, right? Expose it as a HTTP server. So I would imagine you would keep the API part in Scala, but then in your everything that's inside your resolvers, then you could use Java. The only problem you're going to have is the Java, if you use not case classes, but Java types, the auto derivation and semi-auto derivation won't work. So either you write Scala case classes, or you need to write your own schema for your Java types. So technically possible, but might be a little bit annoying.
Okay, and then I have a question about the project. Like, how are you running the project? Are you accept contributions? What's kind of your contribution model, and how much community support have you gotten in that regard?
Yeah, there are actually quite a lot. Maybe I can switch quickly to the show the GitHub page. There are actually quite a lot of contributors. You can see 126. That's actually a lot. If you compare to the number of stars, that's like 1 out of, I don't know, 6 person who contributed. So yeah, it's very friendly to contributors. A lot of features were added by contributors. There are actually 3 other maintainers that were initially contributors, and they contributed a lot. So now they are also maintainers. They can also review and merge PRs. So we are 4 working on this, like with maintainer, let's say, roles. But yeah, it's very open to user issues or pull requests. There are some issues that are tagged as a good first issue. So if people are interested, they can even contribute if they want. But yeah, very open to contributions. If you use Caliban at your company, you can also add your company in there. There are not so many. There are way more that I know of that are not in than the one that are in here. And there is also, by the way, I didn't mention it, but there is a Caliban channel on the Zio Discord. If you have any question anytime in the future, you can head up there. I'm often there, but not just me, like the other maintainers and other users are here and answer questions.
I was going to ask, like, what level of enterprise involvement have you seen? I guess people are listing their things there, but I'm suspecting that you also get PRs and support requests, right? Have you fielded support requests from companies who have this in production?
Yeah. I have all kind of feedback, either request or like many of them, actually most of them maybe come from people who are using it at work. But yeah, not all. I mean, many contributions are done like by people as individual, not necessarily as a company, or like I don't really know like all of the like where people are working even when they submit a pull request. I've heard that some pretty big companies actually were using it, but I don't even know to which extent. Yeah.
Okay. And so I'm not that familiar with the GraphQL landscape, and I have not implemented too many GraphQL servers in other languages. What is your view of like how this may improve on implementations in other languages? Like, is this going to save teams time? Can this do things that doing this in, Go or Python cannot do? Like, how much of a win is using Scala for implementing a GraphQL server?
I think one of the experience that I have with other language and even like other Scala libraries is that usually you have to write a lot of boilerplate. Maybe it got a bit better like over the years, but it always bothered me that you have to define your schema in one place and your resolvers in the other place. And when I built Caliban, the first reason why I built it is that I had a REST API that I wanted to turn into GraphQL. So I already had all that code that were already existing, and I realized that if I want to like expose it as GraphQL, I need to write so much boilerplate to define my schema and then to say I have this field, this field, this field. And I was like, can't I just reuse all my existing code? Like all my, maybe for the root operation, okay, I can describe them, but everything underneath is already existing. I just want to reuse that. So that's how I got the idea of working on Caliban. I was like, I just want to derive a schema from that existing code. So I think that's where you benefit the most, when you the ability to reuse existing code, and also the low amount of boilerplate that you need to write basically to get this working. So I think that's where Scala shines, like the concisiveness, and also expressiveness of types. That's something that I really like. I mentioned what we do in Caliban client, like generate client code from the server and then compile time check that your queries match the server schema. That's quite rare. That's also a real benefit, in my opinion. So yeah, I think that's those are where you benefit the most using Scala.
Okay, and I know we have another person with their hand raised, so one more question for me. It seems like this project has survived the transition from Scala 2 to Scala 3. What are your views on that? Was it very difficult? Has Scala 3 made the job a lot easier? Do you like the new metaprogramming tools? Is the syntax way better? Or was it a pain? Was it worth it?
So Caliban supported Scala 3 actually pretty early, maybe a year, or maybe a little less than a year before the actual Scala 3 first release. So quite very, very early, actually. It was a bit of a pain, but for several reasons. One was that not all the dependencies were available at the time. The main issue was the parser library. So to parse GraphQL queries, we use a library called FastParse, and it's only been available on Scala 3 since maybe, I don't know, 2 or 3 months ago. So for the whole time where it was not available, we had to write another parser using another library. So we had a one parser for Scala 2 and one parser for Scala 3. That was quite annoying. Like the code was duplicated, the whole code was duplicated. The good thing is at least the parser doesn't change much once you wrote it. The GraphQL spec doesn't change every other day. So once it was done, then that was okay. But now this is resolved. There is only one parser now. It has been unified, so that's great. Another problem that I had was that at that time well, it's a good and a bad thing. Now it's pretty good, but at that time it was not. It's the type class derivation. So for Scala 2, we are using also a library called Magnolia that is doing type class derivation for case classes and still traits. In Scala 3, there are native type class derivation features. So at that time, Magnolia was also not available on Scala 2. Oh no, sorry, on Scala 3. Now it is, but at that time it wasn't. So I decided to write the Scala 3 part by using the native type class derivation feature. But because Scala 3 was still not released officially, there was a lot of bugs. So I ran into a lot of like compiler crashes and so on. But I finally succeeded. And also it was hard because of the lack of documentation, because it was very early. But I made it. I succeeded, and the bugs have been fixed and so on. So now I actually much prefer the code for Scala 3 for type class derivation than the code for Scala 2, because the Scala 2 one uses a library that is a bit of a black box, while for Scala 3 now it's my own code, so I can tweak it, I can modify it the way that I want. A little bit more recently, like I think it's in Caliban 2.1 maybe, or we added the support for the derives keyword in Scala 3. And that is really cool because that allows you to really cut down the boilerplate. Instead of adding like an implicit var or given for each type, you can just add derives. So that's really nice if you use Scala 3. So yeah, it was a little bit of a struggle, especially at the beginning, but now it's really sweet. And I think the usage is even better Like for example, also if you use Zio environment with Scala 2, there is some, instead of calling schema.gen to create your schema, you need to create a generic schema of your environment and call that gen function instead of the schema.gen. Like with Scala 3, it's way simpler. You just call schema.gen, it just works, even if you have a Zio environment. So as a user, it's much nicer, I think, on Scala 3 now. Yeah.
Okay, awesome. Thank you.
Awesome. Yeah, we have a question from Navid. I hope I'm pronouncing that correctly.
Yeah. Good enough. Sorry, can you move back to like a couple of slides ago when you were talking about interceptors?
Yeah.
Yeah, that's the one. So you just like pulled a server request kind of out of thin air, and that's like not in the type parameters.
Yes.
I just wonder how you got that.
So actually, if I go back to here, interceptor.
Oh, okay.
From
All right,
yeah,
I see.
it's basically from R1 to R, plus it gives you the server request. So the server request, you don't need to provide it because it's provided by Caliban directly.
I see. Yeah, I didn't really pay attention here because
Yeah.
So one more question about the part where you were. Essentially, what if half of my API is auth, it requires auth, and the other half doesn't, right? And I kind of need to alternate that. Hey, if you have the auth, then show this, and if you don't have the auth, then show that. You need some kind of fallback mechanism. And I wonder, like, where do you apply that? Do you apply that on the interpreter level? Like you have two different interpreters, and then you say, "Hey, try this," and if it fails, then try that. Or do you do that on a HTTP level?
Well, it really depends. Well, this system gives you a lot of flexibility, right? So you can either like at each field level, you can say like this field requires a context or not, and in the resolver you can try to access this context. That's one way. One way is you don't, but that way kind of pollutes your resolver a little bit. With that, maybe you don't want, maybe your resolver are just business logic and you don't want to have that everywhere. In that case, one way could be to do it with wrappers, but it may be a field wrapper, for example, or so a wrapper can also add access the context. So you could have all your fields that don't access the context, but your wrapper access the context. Or you could do it at the interceptor level as well. But the interceptor doesn't know which fields are requested. So if it's depending on which field it is, you cannot do it at the interceptor level. So it really depends on your case. If it's per field, I would say maybe at the wrapper level or directly in the resolver. Like if you say maybe with a fallback logic, maybe it has to be at the resolver level then, because that's the only way where you can say execute this or execute that, maybe. If it changes the actual resolver, if it's different logic.
I see. But like, are interceptors not combinable in any way? Like if I have two different ones,
you can have multiple interceptors. Like when you call intercept, you can call intercept like multiple times. But still, we are still at the HTTP layer level. So there is no knowledge of GraphQL here.
Oh, okay. Okay, yeah. But I was wondering, like, if one of them fails, it already produces like a happy response or something. So you could just say, hey, if you get this, then fall back to the other guy. But I think I kind of understand what you mean, that I could do it at the resolver level, but then the wrappers work too. But I guess I have to play around with it. Thanks for the options.
Yeah, basically, if there is anything you can do here, it's okay. But if it's something that you can only do when you have some knowledge of GraphQL, let's say, depending on which resolver it is or what the client called, then you just inject into your environment and then you use it downwards in the resolver or wrapper.
Yeah. Okay. Thanks. Yeah, I can just use an option.
All right. Any more question? Okay. Just checking the.
Well, how
Checking
are you
back.
doing on time, Pierre? Do you need to go soon? Or?
Oh yeah, it's okay. Yeah, I kind of need to go to work, but all right. Yeah, I can stop. Yeah, okay. Well, I hope that was interesting for everyone.
That was very interesting. Thank you. It was a great presentation. One thing I wanted to mention again was that Pierre does have a GitHub sponsorship set up. I think that software like this benefits the community greatly. It's obvious of a lot of value to everyone. I think it's worth buying Pierre a beer once per month myself. So I'm going to do it. Oh, I'll sign into that in a moment. So thank you.
Well,
I
thanks.
appreciate it. Everyone check out the repo, which I can now put in this tab. I'll go back to that in a moment. And I appreciate your time. I appreciate you getting up early before work in Korea to present this to us. It was a fantastic presentation, and for taking the time to do that. And I think let's see, that's about all we have. Are there any other questions or any comments before we wrap it up? I know we're a little bit over time, so I don't want to keep people too long. I will just remind people, I also want to give a thanks to Ibrahim for kind of moderating. Thank you very much. That was a great help, and for bringing Pierre into to the meetup. I'd like to remind everyone that we welcome all participants to speak on a topic, whether you're an expert or it's just a project that you've worked on or something you've just learned about. You are the Scala community. You are the meetup. You are the people who make this happen. So if you'd like to present anytime, let me know. We welcome guests. And thank you all for attending. So,
thanks, Joe. Thanks, Pierre.
So thank you. I don't think I can stop recording until people leave. And so any other comments before we wrap it up? Okay. Thank you. See you next month.
All right. Bye-bye.
Thank you so much, Pierre. Bye. Bye, Steven. Bye, Ivan.
Thank you.